Okay, so section 1.3 is about congruent segments and using the midpoint. So it says when numerical expressions have the same value. Okay, all numerical expression means is like I don't know, 2x plus 5 equals 4x plus 5 or something. Okay, so if they have the same value, you can say that they are equal. Okay, so 4 equals 4. Okay, so if you work that out and get all the x's to one side and all the numbers to another side, and it works out, you can say that they're equal. Okay, if two segments have the same lengths, then they are congruent segments. So there is a big difference in geometry. There's a big push for this. Okay, there's a big difference between equal and congruent. Now, or equal and equivalent are two words that you hear quite frequently. Okay, so some good examples of this. So we can all agree that 4 equals 4. Okay, there's no argument there. 4 definitely equals 4. All right, but then there are also things like, you could think of it kind of like similar. So me and my sister are similar. All right, are we exactly the same? No. Okay, but are we pretty close? Yes. And there are many other instances. So there is a difference in the notation. Equals, you guys know an equal sign. Okay, and congruent, if you're looking at the slide, you can see the sign, but it looks like an equal sign with a little squiggly on top. Okay, it means congruent. It does not mean equal. So, and I will hit you hard on this because just because something's congruent, does it look equal? Does it look equivalent? Yes, it totally does. Okay, but is it actually equal? No. So it says that if AB equals CD, so if this one equals this one, okay, they used equal, then you could say that AB, okay, segment AB, is congruent to CD. Now the reason why there's a difference, so these ones are noted with a number, okay? And you can say that 1 equals 1. We know that 1 equals 1. But this one, it doesn't have a number, okay? It has a midpoint and it has a segment. So we could say that they are congruent, okay? So, I don't want to say essentially they mean the same thing, but essentially they kind of do mean the same thing, but they don't, okay? And I know that sounds tricky, but... Okay, so we're going to look at congruent. So it says, are AC and BD congruent? And here's what I'm going to tell you. Even when you do the ones by yourself, don't write me just yes or no. Okay? Do not write me yes or just no. Okay, you can show a little bit of work. Oh, thank God. They're redoing the water lines in Monroeville, and so like every other day we have no water. And then we have to go on a boil stupid thing for like 3 days every single time, and it's just crazy. So, anyways, you know, our boil alert's been lifted, thank God. Okay, so we need to look at AC and see, well, and most of you guys did really, really good, except for on one slide, but not even one slide, one problem on one side. You guys did really good at looking at the segments and counting them, so you should do all right on this part, okay? So we need to look at AC. So A is at -2, and C appears to be at 5. The length of AC, and this is what I want you to do, okay? I don't want you to just write me yes or no, okay? So you could say AC equals, and from 0 to 2 is 2 units, okay? And then from 0 all the way to C is 5 units. So 2 plus 5 is 7. So we could say AC is 7. And then we need to look at BD. Okay? And let me erase up here. So BD, our B is at 3. And our D is all the way at 10. So the difference in between them would be 7. So BD is 7. So are they congruent? Okay, are they the same? And this is where congruent and equals gets tricky, because are they equal? It's fair to say that the numbers are. Okay, so now you may write yes. Okay, do not write me just yes or no. Gosh dang it, I wish this cough would go away. Okay, the next one says, are BC and CD congruent? So let's look at BC. BC starts at 3 and it ends at 5. So from 3 to 5, we got 3, 4, 5. It's 2 units. Okay, so BC equals 2 and CD equals, we don't know. Okay, so now let's look at CD. So C starts at 5 and D is at 10. So from 5 to 10 would be 5 units. Okay, so BC equals 2 and CD equals 5. So are they congruent? No, they're not the same number. They're not even close to the same size segment. So just write no. Okay, so it's really just a matter of counting the length of one segment and the length of the other segment and saying yes or no, are they the same or not, okay? Okay, so that one shouldn't be too hard for you. Okay, now, the midpoint of a segment is the point that divides the segment into 2 congruent segments. Now, all I want you to think about is that even if you feel your desk, look at your desk, right? Your desk is a certain length, however long. It is fair to say that you could split that desk equally in half, in 2 sides. That middle point, okay, that equal point of halfway, okay, is a midpoint. So if we're looking at a segment that's 4 units, okay, then A would be at 0, C would be at 4, the midpoint would be 2, right? It's the halfway point. Midpoint is the halfway point, and we've done that in algebra, but it's just a matter of looking at it, okay? So, the word bisect, okay, so a point, line, or ray, or other segment that intersects a segment at its midpoint is said to be the bisect of a segment. Okay, so what that's essentially saying is that if you have a point AC and it's at 0, 4, okay, there's a midpoint at B, which is 2, okay? If you drew a line through B, okay, that line bisects, or it goes through the midpoint of that line, okay? So bisect to me is another word for midpoint. Is it technically? No, but essentially, yes, okay? So midpoint means halfway. So it says, we're looking at this next one, and it says Q is the midpoint of PR. Okay, so we have the whole entire line segment of PQR. Okay, so Q is the midpoint of PR. Okay, so and we know that midpoint means the halfway point. So if we split this segment exactly in 2 pieces, this is half and this is exactly half. Okay, so it says find X, find PQ, find QR, find PR. Okay, so it wants you to find the X, it wants you to find the length of this segment, and the entire segment. Okay, so if you have a midpoint, and we think about our segment addition postulate, okay, so our segment addition postulate says this half of the segment plus this half of the segment equals the entire segment, okay? So, and I know some of you guys are like, well, you didn't give us the length of the entire segment. That's totally okay. So, because it's the midpoint, this one should equal this one, okay? If the whole thing is 10 units, this one should be 5, and this one should be 5. Okay, is it really 5? I don't know. Okay, so we can set each of those equal to each other. So we can say 6x minus 7. 6x minus 7 is equal to, because we know that it equals the other side because Q is the midpoint, 5x plus 1. Okay, so we can set both of those equations equal to each other and solve. Okay, and we know letters go on the left, so anything with a letter needs to go on the left, and numbers go on the right. Okay, so we need to move anything with letters over to this side and anything with numbers over to this side. So, and by left and right, I mean left equals, and then there's the right side of the equals, and you can't really see that at all. Okay, so the left side, you got left, oh my golly, the left side and the right side. Okay, that equal sign separates them. So, we need to solve. So, 6x, is that a letter or a number? Well, it's kind of both, but it does have a letter, so it can stay there. The -7, is that a letter or just a number? Well, it's just a number, so it needs to be moved, so we do the opposite. It's a -7, so you say +7. Okay, if you do it to one side, you have to do it to the other side. And some of your guys' algebra is not that great, so I would probably just write it over off to the side before trying to add and subtract everything together. Okay, so now we have 6x equals 5x plus 1 plus 7. Okay, so once again, keep looking at the left side of the equal sign. So I got a 6x, that's a letter, so it can stay. Now I got an equal sign, so now we're on the right side of the equals. Okay, 5x, is that a letter or a number? Well, it has a letter, so it needs to be moved. And if there's no sign in front of it, it's a plus, so we need to minus it. So if we do it to one side, we have to do it to the other side, so minus 5x. So now on this side, we have 6x minus 5x equals 1 plus 7. Okay, and then we can go through it back and check and say, well, I got a letter equals, now I'm on the right side, number. Alright, so we can go ahead and combine the x's together and combine the numbers together. So 6x minus 5x is 1x. 1 plus 7 is 8. Okay, now a 1x doesn't change anything, but you're more than welcome to go ahead and divide by that 1. Okay, your last step is always going to be divide anyways, but so we can say divided by 1, both sides. Okay, we need to get x by itself. X equals, and 8 over 1 is 8 divided by 1, which is just 8. Okay, so now